G'day everyone. Today we're going to be looking at inverse functions and sort of what they mean. And these are things that we know about from times before. So just to sort of like give it a quick sort of to have a look at what's going on. If you've got a function that adds 3, so if you've got f of x equals function that adds 3, the inverse function of is which will is the function that undoes the original function. So it does the opposite, it goes backwards. And so if this function adds 3 to the function, then the inverse function will be x minus 3, the function that undoes it. If you've got a function that squares a value of x, then the inverse function will be the square root function. Okay, actually the plus or minus, we'll have a look at that in a second. So it's just the function that undoes it, makes it go backwards. And if you think of f of x as a machine, the f of x, if it's a machine that adds 3, and so you put like 10 into the machine and 13 comes out of the machine, if you're going in there like that, then f of x is producing it going that way. Well, f negative 1 of x is the machine going the opposite way, so going from there to there. So it's going backwards, it's undoing what f of x does, so it's the opposite of it. Hope that makes a little bit of a sense. And so, like one other one, other ones that we know, like sine x. All right, what's the inverse function of sine x? What's the function that undoes sine x? Is arc sine x. That's the inverse function of sine x. It undoes it. It goes backwards. So that's what we're talking about when we talk about inverse functions. So in the next video, we'll have a look at how you sketch them and graph them, and etc. We'll look at a bit of it today. But to find inverses, what we do is we do the following. So if you've got y equals f of x, to find an inverse, we swap x and y. And what that swapping of x and y does is it's virtually reversing what's happening, because y and x are swapping roles. And so because they'll swap roles, it undoes it. It makes it go backwards. It swaps it. It becomes all upside down and goes backwards. So we swap x and y, and then we solve for y. And that will sort of rearrange things. You'll see how that works in a second. And that's it. That's all you do to find an inverse function. And because x and y have swapped, then the domain and range just swap. And so if you're trying to find the domain of the inverse, that's just simply the range of the original function. And if you're trying to find the range of the inverse function, that's just the domain of the original function. So all we're saying there is the domain and range just swap between the function and its inverse. Hope that makes sense. To make it make more sense, let's have a look at an example. So find the inverse of y equals 2x squared minus 1. So I'm going to do this algebraically first, and then we'll have a sort of talk about what it means graphically, because that's always like important to have a think about that. Okay, so I've got y equals 2x. So step 1 was to swap x and y over. So here we're going to do that. So instead of writing y, I'm writing x. And instead of writing x, I'm writing y. So 2y squared minus 1. I've just swapped over the x and the y here. And now what I need to do is just solve this for y. Okay, so I'll bring that negative 1 over to this side. So x plus 1 equals 2y squared. I'll take that 2 across. I'll also just swap sides while I've got it here, because I like y being on the left, as most people do. But I'm just dividing by 2, so that's x plus 1 over 2. And then I'm going to take the square root, and just be careful here, because you're solving y squared equals something. When you solve for y here, yes, you are going to get the square root of x plus 1 over 2, but also you're going to get plus and minus. So just always remember that whenever you're doing it. Whenever you're solving x squared is equal to something or other, and then you go, therefore, x equals the square root of whatever that something or other is, always do plus and minus. So always double check that. Always, always, always. And so what we have here, we've solved that for y. Why is my pen not working? There it goes. What we have here is that's the inverse function of the original function up here. Okay, that's the inverse function. And we'll have a look at whether it's actually functioning. I'm saying function, but it's having a look at that. I wonder whether it's actually a function. And so we'll have a look at that. Let's just quickly sketch to see what this thing looks like, first of all. Okay, so y equals 2x squared minus 1. What does that look like? Well, 2x squared is the original graph of x squared, but just with a dilation factor 2, and then it drops down by 1. So it looks like, sorry, I'm going to excuse my drawing here, but it comes down to -1. So it looks a bit like that. And so I'm just going to quickly write down the domain and range to have a quick think about this. So the domain, all real values, all the x's are defined, and the range, sorry, I did a little dot, goes from -1 to infinity. Okay, so that's the range of that function there. And let's have a think about what this graph looks like. Okay, so x minus 1, I might just rewrite that, sort of like think about this. So I'm just going to put half out the front, x plus 1. So you can see that there's a dilation of a factor half there. So if I have a look, so what does this thing look like? Well, the square root of x looks like that, right? It looks like that. That x plus 1 there, that's going to make it move to the left by 1. Okay, so I'll just get rid of that. And so what it's going to do is it's going to move to the left. So it's going to instead hit there. And it's going to come up like that. And so at -1 here. Okay. So that's the top part. That's the plus. That's the plus part of it there. So why is my pen doing funny things today? That's the plus bit there. Because it says plus and minus, then we need to do the other half of it as well. And I'll just do it in green just to show you. The negative part of it is exactly the same as that, but it's got a y. It's reflected in the x-axis. And what it looks like is the other part of it here. So it looks like that there. Okay, so that whole thing there, the whole thing here, struggling with the pen, that whole thing there is the inverse of that original function. And what you notice when we actually have a look at this, is it's actually identical to it. But what has happened is the x's and y's have been flipped, right? So if you have a look at it, so it's actually this whole thing. It's sometimes hard to see, but that whole thing up here, that is being sort of flipped, where the x's have become y's. And what actually happens, and you'll see this with all inverses, is that it gets mirrored along the line of y equals x, which makes sense because x's have changed to y's and the y's have changed to x's. And so everything on the original graph gets flipped along this line, reflected along this line, so I should say, not really flipped, to become the inverse function. So let's have a think about it. Let's just get rid of some of these messy scrawlings I just did. Before we have a look at. So we can write down the domain and range. So let's do that. So just before we sort of move forward with talking about actual functions. Okay. So I've got this here, right? And at the moment, the domain comes from the range of the original function. So that'll be -1 to infinity. And the range is the domain of the original function, which is r. Okay, and that you can see that from the graph as well. That's perfectly seeable from the graph. So we've got our domain and range. So the next question is this a function? All right, and if you remember back to the original when we defined what a function is, to define whether it's a function or not, we need to do the vertical line test. Okay, so the vertical line test, is this thing a function? So if we draw a vertical line through that function, it should only hit the function in one spot. That's what the definition of a function is, because we want a many-to-one or one-to-one function. We can't have a one-to-many function. And so that vertical line test is a big fail. So that is not a function because it hits at two spots. It hits there and it hits there. That line crosses twice, and so this is not a function. Okay, so it's not a function. But what we can do is think about, well, what would create a function? Okay, so if we think about what we could do. So this is not a function. Not a function. Okay, so at the moment, if this question said to you, find the inverse function of that, then you would get this answer here, but you would say, well, but that's actually not a function. Then the next part of the question might be saying, can you do a domain restriction on the original graph so that its inverse is defined, so it does have an inverse function? And so let's just have a look at that now, okay? And so if we're asked to actually define it, what we could do is have a look at the original graph. So coming back up to the original graph up here, I'm just going to get green. The original function, could we actually have a look at it and see, well, could we define part of it so that the inverse will be defined? And so for it to be defined is we do a horizontal line test. So, as we did vertical line test for the inverse, let's do the horizontal line test for the original. And you can see there the horizontal line test has failed. That means that it's not a one-to-one function. Okay, so there's multiple points that are defined from x to y. And so because it's failed the horizontal line test, that will mean that the inverse function is not defined. It's not a function. Okay, so it'll always be like that. And so the question is, well, what could we do to this original graph to make it so that it does pass the horizontal line test? And so what we could do is we could say, well, we can either just have this first half here, we could have that half, that would pass the horizontal line test, or we could do this part here. Okay, so either way, that will define the inverse function and everything will be a-okay. And so for the sake of today, it really doesn't matter which half you choose because both will work. I'm just going to choose that half of the function to be the half that we define. Okay, so if I define, actually I should learn my lesson from one of the other videos where I went too low. So if I define the original function to be equal to, what was it again, 2x squared minus 1, where, and let's define, and let's go, instead of going all r, we're just going to go to 0. So we're going to go from negative infinity to 0. Now we're going to restrict the domain just for that first sort of half of the graph. And then what will happen then if we have that first half of the graph, when it gets reflected in the y equals x line, why is it doing that today? I don't know. When it gets reflected in that line, what we're going to get is we're going to get the we're going to get the top half of that line. Okay, so when it gets reflected in the line, you can sort of imagine the bit that we're going to get. Okay, so I should actually, I'll do it on Desmos. I'll just quickly go to Desmos to show you. Okay, because I did this before. I've set it all up. Okay, so what we get is if we bring those sort of the inverse in, it's going to look like this, and it's a little bit hard to imagine, but if you can imagine the line y equals x, and I'll actually put it in there. There's the line y equals x, and it's going to be reflected in that line. So if we're only choosing this first half here, this first half of the line, and that gets reflected in that line, then you'll see that this lower half will be the bit that ends up being reflected. Okay, so when it comes out, so the green part of this line will be the bit that's reflected. And so if we go back to my original drawing here now, what we can say is that, well, what's left if we define that function will just be, I'll just get my yellow highlighter out, will just be this section down here. So that will be the part that's left over if we reflect that in the line. I hope you can see that. It takes a while to get used to seeing what the bit will be once it's reflected in the line y equals x. But we will get that particular sort of half of the, I guess, the sideways parabola in there. And the defining of that will create an inverse. It will allow us to have an inverse function. Okay, so it will create an inverse function because it will be defined. It will then pass the vertical line test because it will only be that bottom half. You'll only get one spot for each vertical line test that you do. And so that's how we create an inverse. And sometimes you'll be asked to restrict the domain of the original function so that the inverse does exist. And that's the sort of the concept about how you do it. Just a quick little thing before we finish this video is just going back to Desmos now. You'll notice that, and this graph does look a bit complicated here looking at this, but you'll notice that the graph of the function, so the original function is this red line. The inverse function is the blue and green line, okay, sort of, I guess, like put together. If you're ever asked to find where the function and its inverse function intersect, have a look at where the red line and the blue lines intersect. I'll just take this off again, okay? I'll just get rid of it. It makes it look a bit confusing. But have a look where they intersect. So that's the first intersection right there, and that intersecting point is at 1, 1. Okay, so at the point 1, 1 where they intersect. If I look at the other point where they intersect down here, where is it? There, they also intersect at negative half, negative half. And this is what so you might notice was like, well, the x and y values are the same for those intersecting points. And that is always true for an inverse function and its original function. They will always intersect at the line y equals x. So if I put y equals x back in, you'll see that it always intersects there, okay? And yeah, that is always true. And so one little shortcut, I'm not going to show it to you, but one little shortcut, if you're asked to find the intersecting point between a function and its inverse function, instead of trying to solve the function, I'll just write it down. Instead of trying to solve, sorry, just get back to where I was. Instead of trying to solve the function is equal to its inverse function, that can actually be a bit of a nightmare sometimes. Solving that equation, like here, you'd have to solve 2x squared minus 1 is equal to, what was it again? Negative half x plus 1. These can be a bit horrible to solve, having to solve that if you're just trying to find the intersecting point. A much easier way to solve it would just to be to go, well, it's where 2x squared minus 1, so one of the functions is just equal to x. Because that's where it crosses the line y equals x. Much easier to solve this than that there. Okay, so that's just a little tip. If you're asked to find the intersecting point of a function and its inverse, much easier to solve one of the functions equal to x, and that will give you your answer. Hope that makes sense. See you in the next video.